All right, everybody, this is a guided walkthrough for the Picker 4 challenge from picoCTF as part of the Pico Gym exclusive series of challenges. So let's talk about this challenge. It's a medium challenge in the binary hacking category. The description of the challenge says, can you figure out how this program works to get the flag? Additional details will be available after you're launching your challenge instance. So this is one of those challenges where we need to launch a virtual machine with this button over here on the challenge that's labeled launch instance. So just click on that. And then what this does is it creates the environment where we can solve the challenge. So after a few seconds, you're going to see a command over here, connect to the program with netcat, and we've got a netcat command. So we're not going to be using the netcat command immediately. The first thing we're going to do is we're just trying to figure out how the program works. And figuring out how the program works and how to break the program is the essential of what binary hacking is. So there are two links. The program source code can be downloaded here, and the binary can be downloaded here. This is pretty typical of these binary hacking challenges. So the first link, we're just going to highlight over it, and then we're going to copy the link. We've got that first link. We go over to the web shell, and then we do the wget command. So wget, paste in the address, and then download the C file. The next thing we're going to do, we're just going to go back. We're going to do the second link as well. So highlight that, copy link, and then use the wget command again to download the file. Okay, so let's take a look at what two files we have here. So we got picker4, which is a binary file. We can run file on this one. It tells us it is a ELF 64-bit LSB executable, and so x86-64. So this gives us a lot of information about what this is. So because we're doing binary hacking, we need to understand what kind of binary we're looking at. So this is an ELF file, which is a standard executable file for Linux. It's 64-bit. It is a least significant byte executable, which means that all of the bytes are being fed into the binary in, well, from right to left instead of left to right. And yeah, so all sorts of great information here. So the first thing we need to do with this file is we need to make it executable. Otherwise, we're not going to be able to interact with it. So just going to give the chmod +x command to make the file executable. Then we can just run the file really quick. So when we run the file, it says enter the address in hex to jump to, excluding the 0x. So so what the binary wants from us is it wants a memory address. We'll talk about this in just a little bit, but we can just exit out of this program first, and then we can take a look at the source code. So most of the time in these binary hacking challenges, they're going to give you the binary that you need to hack, and then they're going to give you the source code. The source code is provided so that you don't have to do reverse engineering. You can just take a look at the code itself to understand the logic of the program. So we're just going to take a look at the C file. And we see over here we've got a few different functions. So there's a print segfault message over here. We've got a win function over here, and we have a main function as well. So we see here in the main function, it prints enter the address in hex to jump to, excluding the 0x. And apparently what you can do is you can jump to any part of the program in the memory to try to execute it. And what we want to do is we want to run this function right here, the win function. So the win function it prints out you won, and then it opens up a file, flag.txt, in read mode, and then it reads the contents and reveals it to us. So this is the function we want to access. Let me get out of here real quick. In order to run this program correctly, you need to have a flag.txt file in this directory as well. So we're just going to echo out something and redirect it into a file called flag.txt. So we'll do HackerFrogs like and subscribe. Okay, and then we've got the flag file here that we want to access. What we want to do is we want to find some way to run the program that gets us the contents of the flag.txt file through running the program. So the type of challenge that's being illustrated here, let's talk about this. So this is picoGem exclusive Picker 4. Okay, so this challenge is an example of a Ret2Win binary hacking challenge. So Ret2Win is like a category of binary hacking challenges. It basically requires us to run a function that gets us the goal of the challenge, which is the flag. So we can see inside of the win function, it opens up the contents of flag.txt, and this is the function we want to access. So in Ret2Win challenges, the goal of the challenge is to force the program to run a function which it normally wouldn't run under normal circumstances. So if we take a look at the program code, oh, it's not this end, not this one. If we inspect the program code, we see that the win function is defined, but the win function is never run inside of the code itself. So in the main function here, there's no mention of the win function, which means it doesn't run under normal circumstances. So yeah, we need to find some way to get the program to run the win function. And here it says enter the address in hex you want to jump to, which means we could probably run the win function if we know the memory address of the win function. And we can actually figure that out. I'll teach you how to do that. So the program gives us an easy way to run code according to its memory address. So if we know the address of the win function, we can run it and complete the challenge. So when we run the program, enter the address in hex to jump to, and we want to run this function here. So how do we find the function address? There are a few different ways to find the memory address of a program function, such as the object dump command or the Radare2 debugger, and I'll show you both of these. So we can go back to the web shell. So one way we can take a look at where the functions are is run the object dump command. So object dump, and we can get the disassembly of the entire program, and then give the name of the program. So object dump -d picker 4. So this gets us the entire disassembly of the program, and we're looking for the win function. If we know we're only looking for the win function, we can just grep this out, grep out win, and this is the address where the win function resides. So this is hexadecimal, hexadecimal 40129E. So the interesting thing that we need to note is that the hexadecimal memory address is in pairs. So this is a pair. This is 1 byte here. 9E, 12 is another byte, and 40 is another byte. It's not all globbed up together. Okay, so this is one way of getting the memory address. So this is the memory address. The other way we would do it is we would do this inside of the debugger. So our favorite debugger is the Radare2 program. Radare2 is a very powerful set of tools for reverse engineering and binary hacking. So we run Radare2 in debug mode on Picker 4. Okay. After we do that, we open up the Radare2 debugger, and we can then analyze the binary. So in Radare2, you do AAA to analyze the binary. Here. Okay, so after we analyze the binary inside of Radare2, we can get all of the functions. So after we analyze, we can do AFL for all function lists. This will give us every function in the program. And the thing is that it spits out a lot of output here. If we knew the name of the function we wanted to look up, we could just grep it out again. So clear the screen, run all function list, but pipe that into grep.win, and it shows us the address of the win function over here. So in this case, it's called sim.win, and this is the memory address. So we've got the memory address. We use two different methods. We're just going to copy this particular memory address. We can exit from here afterwards. And so we know the address of the function we want to run. Let me take a look at. So keep in mind the memory addresses are often expressed in hexadecimal numbers. So this is a hexadecimal number here, and this is also a hexadecimal number. So this is explicitly a hexadecimal number because it begins with the 0x, and 0x is, what is the word? Is the denotation of hexadecimal numbers, so 0x. So whenever you see the 0x in front of a number, it's probably in hexadecimal. Okay, so, sorry, wrong terminal here. Okay, so we run picker4 and then enter the address to hexajump to excluding the 0x, paste in the address that we got, hit enter, and then it says, you won! HackerFrogs, like and subscribe. So this is the contents of the flag, which means we managed to compromise the binary to get the flag. So let's see if we can do that in the challenge. So the challenge says connect to the program with netcat. So this is the netcat command we would use to do that. Go back to the web shell, paste in the command, and remember, this is the hex address. So we're just going to copy that. And then this is, so the netcat command lets us access the program that's running on the server. So enter the address in hex, paste in the address, hit enter, and then you won. picoCTF never jump to user supplied addresses. Okay, good advice. I'm just going to copy this, and then we're going to go back to the challenge. We can paste in the flag and then submit the flag, and then we're finished. Everybody, that was a guided walkthrough for the Picker4 challenge from the picoGym exclusive category in the picoCTF platform. All right, if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.